Today we're going to look at transformations of functions. And so before we can do that, there's some functions that are important for us to remember throughout the semester. So the first one is called a constant function. And if you notice, the constant function is basically a horizontal line that passes through the point C. The identity function, which we also call the linear functions, this is going to be the graph of that linear function. And then we have the absolute value function. So notice the equation is f of x equals the absolute value of x. And the graph looks like a V shape. Then we have the quadratic function, which is f of x equals x squared. The highest exponent of x is going to be a 2. And that looks like a U shape. And then we have the cubic function, which is f of x equals x cubed. And so here you can see a graph below. Then we have the square root function, which is f of x equals the square root of x, which is basically an arrow that starts at 0 and shoots to the right. So with these functions, you want to keep these next to you somewhere because we're going to use them throughout the semester. So the best way to use these is to think about these as parent functions. And so a lot of us have parents, and sometimes you might hear people say, oh, you look like your mom, or oh, you look like your dad. And so what they're saying is you have some similarities to your parents. And so with these functions, the same thing. We're going to have functions, for example. Here we have f of x equals x squared. That's your parent function. And then x squared plus 1 looks like the parent function, but it's going to have its own characteristics. And then you have the x squared minus 1, which also looks like the parent function. The important thing here is to remember that these functions will look the same. Okay, so let's explore what happens when we add a 1 or subtract a 1. And so to do that, I'm going to use the computer. I'm going to use a program called Decimals.com. And I can come in here and graph, for example, x squared. So notice the x squared, this is the parent function. And then I'm going to add plus 1 so we can see what happens with the graph. And so you can see that the graph is in blue. And from the parent function, it looks similar to it. But now instead of being here at 0, this vertex part moved up 1 unit. Okay. So what do you think would happen if we subtract the 1? Okay, so now the graph in green still looks like the parent function, but now the graph shifted down 1 unit. Okay, so if we come back to the handout, I'm going to go ahead and graph the parent function. So this is going to be your parent function A. And then I'm going to graph the letter B in red. And so notice that we shifted up 1 unit. So that's going to be letter B. And then letter C shifted down 1 unit. So letter D will be here, or letter C. Okay. So the idea now that we can think about is, in the definition here, it says y is equal to f of x plus c is the graph of y equals f of x shifted c units vertically. So when we added a number, the graph shifted upward. And it shifted up by that number of 1 that we moved. So this is going to be, it's going to shift upward. If we're subtracting like we did here, then the graph went downward. Okay, so in 1314, you were learning how to graph these functions using a table of values, but now we're going to be using transformations to graph them a little bit quicker. Okay, so the difference between the graphs B and C is just the way that they were transformed, either moving upward or moving downward. So let's look at this guy here. Use the graph of f of x equals absolute value of x. So the first thing is to identify the parent function. And this is my parent function here. and to have an idea what the graph is going to look like. So if we go up, so this is what my graph will look like. I'm going to go back down. So I'm going to go ahead and plot that here. So it's a V shape. And so now we have our absolute value and we're adding this plus 2. Since we're adding a number, we can see from the definition that the graph is going to move upward. So that plus 2 is going to cause our graph to be shifted upward 2 units. Okay, so imagine if we could take these dots here. We're going to move up 2 units, so this middle one would end up here. And this green one would go up 1, 2, and then 1, 2. So my graph is now going to look like this. So this is our g of x. So it makes it a little bit quicker than having to do the x-y tables, but you can still do those if you feel comfortable with that. So now let's look at another set. So notice now that instead of having x squared plus 2, now the 2 is being added inside of that parentheses. So it's a little bit different situation. So I'm going to use the computer so we can explore what happens with that graph. So here we have the x squared, but this time we're going to add a plus 2 inside. So notice that the graph this time got shifted to the left 2 units. So let's check what happens if we subtract that x, that 2. So now the graph got shifted to the right 2 units. Okay, so let's keep that in mind. So let me graph the parent function first. So here I'm going to have the parent function. So this is a parabola. So this is letter A for the parent function. And then in green, I'm going to graph letter B, which has a plus 2. And from what we saw in the calculator, the Desmos calculator, the graph actually shifted over 2 units. Okay, so my graph will now be shifted 2 units. So that's our B. And then the C, since we're subtracting, we're going to shift 2 units to the right. So it's kind of the opposite of what we want to do, right? So if it's negative, you go to the right. If it's positive, you go left. So here if we're adding something, we're going to shift to the left. If we're subtracting something, we're going to shift right. So let's try some examples. So here we have use the graph of f of x equals square root of x. So first, that's my parent function. And that's going to look something like this. Okay, so these are just sketches. So this is f of x. And now we want to do g of x. So notice that the minus 4 is being subtracted inside of the square root. So that means that the graph will shift to the right. You don't want to get it confused with this, right? If the negative 4 is outside, then we would say that it's going to shift down. But since it's inside the square root, then we're going to shift to the right. So if I could take this middle point here, I'm going to go over 4 units, 1, 2, 3, 4. And so my graph will look something like this. Okay, let's try a couple of more. So again, my parent function is going to be something like this. Okay, so this is f of x. And then we have g of x is x minus 1, square root of x minus 1 minus 2. So the minus 2 is going to tell us to go downward because it's on the outside. And the minus 1 is going to tell us to go to the right. Okay, so if I could take this point here, I'm going to go downward 2. So 1, 2. And then I'm going to go to the right 1 spot. So now my graph will look something like this. Okay, let's go to the next one. We have x cubed. So remember, x cubed looks something like this. And the -2 tells me to move down. And the +1 tells me to move to the left. So I'm going to use these points here. So I'm going to move down 1, 2, and to the left 1. Let me get a different color. So down 2 to the left 1. Down 2 to the left 1. And down 2 to the left 1. So my graph will look something like this. Okay, so the red one is g of x. So now we have the graph of y equals negative f of x is the graph of y f of x reflected about the, and then we'll fill in the blanks here in a second. So let's see what happens with our graph if we put a negative in front of the x squared. So here's my parent function. If I add a negative, then the graph opens downward, okay? So it flipped over the x-axis. Okay, so letter A, this is the parent function. And then letter B, if you have a negative in front of the parent function, then it's going to reflect on that x-axis. So here we would have the x-axis. If you have a negative in the inside, then it's going to reflect about the y-axis.